Eric Burgess here. We've been told to find the sum of the series n squared minus 1 over 4n squared plus 1. So we say, okay, we know that the series, the sum, is equal to the limit as n goes to infinity of the series, Sn. We're given Sn. So we could say, okay, well, we just need to take the limit of this thing, the limit as n goes to infinity, and I'm going to really quick just do the obvious thing and divide everything by n squared, because this is going to cause us problems. So if we divide everything by n squared, we're going to get 1 minus 1 over n squared, right? Divide everything by n squared over 4 plus 1 over n squared. When we apply the limit, these two bits are going to go to 0, right? Because 1 over infinity is 0, 1 over infinity is 0. So we're going to be left with 1/4. And this is the answer. So just to be clear here, since it's still early in the chapter that we're learning, we have a series here. This is not the same thing as a sequence. This is it's kind of like a special sequence, right? This is like defining the partial sums that are giving us this. So you might look at this and say this looks extremely similar to the previous chapter on sequences, but the limit of this particular sequence is defined to be a series. And that's an important distinction, just like to draw your attention to it. If you don't understand the difference between a sequence and a series, please go check out that video, because it'll be useful conceptually and you'll feel a lot more confident about when to write an S and when to write an A. When I took this class, I had that particular struggle. Maybe you're doing great, I don't know. But for me, understanding that clearly really just made things make a lot more sense. If you have any questions, feel free to drop them down in the comments. Subscribe, of course, and hit that bell icon, and we'll catch you in the next problem.